Section 7.3 is titled Multiplication Properties of Exponents. By the end of this lesson, I want you to be able to use the multiplication properties of exponents to evaluate and simplify expressions. And there are three properties we will discuss. The first property is called the product of powers property, and this states that if you have a product of two powers with the same base, then it will be equal to that base raised to the sum of the exponents. So we have a to the m times a to the n. Remember, the base is the a, so the bases are the same. Then we're simply going to add the exponents together and keep the base the same. So in the examples, we have 6 to the 7th times 6 to the 9th. That gives us 6 to the 16th. We also have 2 squared times 2 to the 4th, and that's 2 to the 6th. So you can see the sum of 7 plus 9 is 16, and the sum of 2 and 4 is 6. And I'll show you why this works with the 2's. If we have 2 squared, remember that's 2 times 2. But we're multiplying it by 2 to the 4th, and that's 2 times 2 times 2 times 2. Well, if we were to write this then as a base with an exponent, count the 2's. 1, 2, 3, 4, 5, 6. So we have 2 to the 6th. This was our 2 squared, and this was the 2 to the 4th. So let's do some examples and simplify. For the purposes of these first few examples, we won't actually take it all the way to the number. I just want to see you using the product of powers property. So we have 5 to the 3rd times 5 to the 6th. Those bases are the same, so we need to add the exponents and get 5 to the 9th. In example 2, we have 3 to the 4th times 7 to the negative 3rd times 3 squared times 7 to the 6th. And remember, it's important when we're dealing with the product of powers property, we can only apply the property to bases that are the same. So we'll start with the 3's. 3 to the 4th times 3 squared. We add the exponents and we get 3 to the 6th. But we also have like bases with the 7's. So we can also apply the property by taking 7 to the negative 3rd times 7 to the 6th and adding negative 3 plus 6. So that'll give us 7 to the 3rd. Negative 3 plus 6. Example 3, we have 2 to the negative 3rd times 2 to the 3rd. So our bases are the same. We simply add the exponents. Negative 3 plus 3 is 0, so that gives us 2 to the 0. Now this one we could simplify further. We do know that anything to the 0 power is 1. We can also apply the property to variables. So we have q to the 3rd times r squared times q to the 6th times r. So we're going to look at the base with q. 3 plus 6, that's going to give us q to the 9th. And we have r squared times r, and what's important to remember here is that if you have just a variable by itself, it has an implied exponent of 1, so we do need to add the 2 and the 1 to give us r to the 3rd. If you'd like to pause the video and try example 5 on your own, we have y squared times y to the negative 4th. Again, remember, the variable y in the middle there does have an implied exponent of 1. So we're taking 2 plus 1, which is 3, plus negative 4. 3 plus negative 4 is a negative 1. And we talked in our previous lesson about simplifying variables that have negative exponents. They need to be taken care of. We can't leave a negative exponent in our answer. So that means in order to make that exponent positive, remember we have to move the y down into the denominator. That's going to give us 1 over y to the 1st, or 1 over y. The second property is called a power to a power. And what this says is that if you have a power raised to another power, it's going to equal the base raised to the product of the exponents. So we have a to the m, and it's being raised to the nth power. So we're going to multiply m times n and get a to the mn power. In our examples, we have 6 to the 7th being raised to the 9th. You can see that 7 times 9 is 63 to give us 6 to the 63rd power. We have 2 squared being raised to the 4th power. 2 times 4 is 8, so we get 2 to the 8th. And I'll show you again with the example of the 2's why that works. If we have 2 squared and it's being raised to the 4th power, it means it's 2 squared times 2 squared times 2 squared times 2 squared, 4 times. That's from this exponent. But 2 squared is 2 times 2. So we have 4 2 times 2's. And now we can see we have 8 2's being multiplied together, and that's how we get the 2 to the 8th. So power to a power property says we're going to multiply the exponents. Let's look at some examples and simplify. 5 squared to the 4th power. So we're going to multiply 2 times 4 and get 5 to the 8th. And now again, for the purpose of these few examples, we won't actually do 5 times 5 times 5 8 times. However, in your homework and on quizzes and tests, you will be expected to compute that number all the way out. Example 7, we have 4 cubed being raised to the 0 power. 3 times 0 is 0. That gives us 4 to the 0, or 1. Example 8 is a little more complicated. We have x to the 4th, and it's being multiplied by x cubed. The x cubed is then being raised to the negative 5th power. So what we need to take care of first is the x cubed being raised to the negative 5th power. Notice that the x to the 4th is not being raised to the negative 5th. It's not in parentheses with the x cubed, so it's outside, and we're going to leave that alone to begin with. Now we need to multiply the power that's being raised to the power. That gives us x to the negative 15th. Now this is like the product of powers rule. We have 2 bases that are the same, so we need to add the exponents. 4 plus a negative 15 is negative 11. And again, we can't leave a negative exponent in our answer, so in order to make that positive, we need to move the x along with the exponent down to the denominator of a fraction, so we get 1 over x to the 11th. Finally, we have the power of a product property. If you have a product, in parentheses here we have a times b, that is multiplication, and it's raised to a power, it's going to equal the product of each of those factors raised to that power. So if you have a product inside the parentheses, a times b, and it's all being raised to the m power, that means we take a to the m and b to the m. So in the example here, we have 2 times 4, all being raised to the 3rd power. Well, that's the same as taking 2 to the 3rd and 4 to the 3rd. Well, 2 to the 3rd is 8, 4 to the 3rd is 64, 8 times 64 is 512. And in your homework, you'll be expected to go all the way down to the number. In the second example, we have 4x squared. So the 4 and the x are inside the parentheses. They're both being squared. So it's 4 squared and x squared. 4 squared is 16. X squared can't be simplified, so we get 16x squared. Let's look at some examples of this type. First, we have x cubed y to the 4th, and it's all being squared. So I'm going to do a little bit of extra work here on this one so you can see that it's the x cubed being squared and it's the y to the 4th being squared. Now we have a power raised to a power, and in that case, that's like the second property we discussed, we need to multiply those exponents. So we get x to the 6th, y to the 8th. Now we can't add the 6 and the 8 and get 14 because our bases are not the same. Remember, your bases have to be the same in order to do the product of powers property. In example 10, we have negative 3x to the 8th, and it's all being squared. So that means the negative 3 is getting squared, and the x to the 8th is getting squared. So if we write this out, we have negative 3 squared times x to the 8th, and it's also being squared. Notice the negative is inside the parentheses here, so it is the negative 3 that's being squared. Negative 3 times negative 3 is 9. Here we have power raised to a power, so we multiply, and we get x to the 16th. So we have 9x to the 16th. If you'd like to pause the video, try number 11 on your own. Make sure you simplify it all the way down. So we have x to the 6th being squared, y to the negative 3rd being squared. I know that when I have a power raised to a power, I have to multiply, so I get x to the 12th. Negative 3 times 2 is going to be y to the negative 6th, but I can't leave a negative in my answer. The y has the negative exponent, so it has to be moved down into the denominator. The x will stay put on top, x to the 12th over y to the 6th. Last, we want to work on simplifying expressions. So the steps to simplify expressions are to first get rid of any negative exponents, make sure that the same base is only appearing once, get rid of any powers raised to powers, get rid of parentheses, and then reduce your coefficients. So it looks like a mess, but we'll be able to clean this up nicely. First we have 3x to the 5th, and it's all being raised to the 3rd power. And we have 2x squared, also all being raised to the 3rd power. So what we have to remember is that the 3 is being cubed, and the x to the 5th is being cubed. That's going to give us 3 cubed, and if you want, you can just multiply that out right away. 3 times 3 times 3 is 27. X to the 5th being cubed gives us x to the 15th. Remember, a power raised to a power, we multiply. Then we have 2 that's being cubed. 2 times 2 times 2 is 8, and we have x to the 6th, multiplying the 2 and the 3. Now we need to simplify the expression. We have 27 and we have 8. 27 times 8, remember this is all multiplication, is 216. Then we have the x to the 15th times the x to the 6th. So we want to add those exponents together because we have like bases, and that gives us x to the 21st. So now we have simplified the expression. If you'd like to pause the video and try 13 on your own and then check your work with mine. First we have 4 being cubed. 4 times 4 times 4 is 64. We have x to the 5th being cubed. That gives us x to the 15th. Then in the second set of parentheses, there's no power out here, so we just have negative 2 and then an x cubed. And I've put the negative 2 in parentheses so we don't get it mixed up with subtraction. Remember, again, it's all multiplication, so we do 64 times negative 2, and that gives us negative 128. X to the 15th times x cubed, we add the exponents and get x to the 18th. Hopefully you got that right, and if not, you can see where you went wrong. For 14 we have b squared times b to the 3rd, and the b to the 3rd is being raised to the negative 2nd power. So we want to take care of that first. I'm just going to bring the b squared along, and I'm multiplying it times b to the 3rd being raised to the negative 2nd. That's b to the negative 6th. Now I have like bases, so I'm going to add the exponents. That's b to the negative 4th. And since we can't leave the negative exponent in our answer, remember that b is going to move down into the denominator to give us 1 over b to the 4th. Number 15, we have 6mn being raised to the 3rd power and 5m to the negative 3rd being raised to the 2nd power. So remember, when you have a product of powers, everything inside the parenthesis gets the third power. That's the 6, the m, and the n. Similarly, in the second set of parentheses, the 5 is being squared, and the m to the negative third is being squared. And that's going to be m to the negative 6 because we have a power raised to a power, so we multiply. Now we need to clean it up. We need to combine our like bases. We need to simplify the coefficients and multiply those numbers together, and also get rid of our negative exponent. So I'm going to take care of the coefficient first. Remember that 6 to the third is 6 times 6 times 6. That's being multiplied times 5 squared. Remember, it's all multiplication in here, and we can do it in any order. 5 squared is 25. When I multiply all that together, I get 5,400. Now I need to look at my variables. I have two variables that are like the m's, so I need to add those exponents. 3 plus negative 6, so that's m to the negative third. And then I had an n to the third. Finally, remember, we need to get rid of all negative exponents, so that m with the negative third exponent is moving into the denominator. 5,400 n cubed all over m cubed. There's your final answer. Next, let's look at some examples where we are multiplying scientific notation, numbers in scientific notation together. These are kind of simple to do. So the first thing you want to look at, we have 1.5 times 10 to the negative second, and we have 3 times 10 to the fourth. So what we want to do first is multiply these two numbers together. 1.5 times 3 is 4.5. So it gives us 4.5 times 10 to the, because we actually have our bases here that are like, we can simply add the exponents. Negative 2 plus 4 is positive 2. So we have 4.5 times 10 to the second. The only thing you have to make sure once you're done multiplying the numbers is that your number is in proper scientific notation. 4.5 is between 1 and 10, so we are finished. If you'd like to pause the video and try 17 on your own, we do 9 times 7, that gives us 63, times 10 to the, we need to add our exponents, negative 6 plus negative 9, that's going to be negative 15. Now remember, with scientific notation, having negative exponents is okay. It just indicates a very small number. But we do again need to make sure this is in proper scientific notation, and it's not. So we have the decimal back here on the number 63. We need to move it between the 6 and the 3 so that we have a number between 1 and 10. And then we have to adjust our exponent. Because we made 63 smaller by moving one decimal place to the left, we need to make our exponent larger. Now be careful because it's negative. What's bigger than negative 15? Is it negative 14 or negative 16? Hopefully you're saying negative 14. So we get 6.3 times 10 to the negative 14. This is a very, very, very tiny number. So if we go back to our objective, can you now use the multiplication properties of exponents to evaluate and simplify expressions? Do you understand the three different properties? Product of powers, power to a power, and power of a product. Also, are you able to understand all of the examples? If not, please make sure that you're asking clarifying questions tomorrow in class when we work on worksheet 7.3.